Classroom looks empty. Why is it? Hello, everyone. How are you guys doing today? Good? Better than yesterday? I hope so. Did you start working on your test correction? So again, a reminder how to upload the test correction. You go to content, and on the left panel is the test correction here. So if you want to see the blank test, I posted both Word format and the PDF format, whichever is convenient for you. You can download that, print that out, whatever you want to do. If you want to print it out, print out and then write the solution on the blank exam. Or if you want to write on the computer on a tablet, you can also do that and then convert it into PDF. So if you print that out, make sure you take pictures, convert all the pictures into PDF, your solution, and then convert into one PDF file. To upload, you click on test correction, and then it will take you to upload option. You upload, and then you're done after submitting. Okay. Due date is next week Tuesday, next week Thursday. I will not accept any physical copy or anything after Thursday. And also your next exam is not next week, but the following week, Tuesday. I posted the review sheet here, and review sheet has a typo, so I'm going to re-upload the review sheet by fixing that. Any question? Okay, so we are starting chapter. We started chapter 5. We are going to finish section 5.2, 3, 4 today. 3 sections. But they're tiny, they're small. So we will be able to finish everything today. So for your homework, next week, Tuesday, midnight, you have section 4.5 homework and quiz. Section 5.1 to 3 for homework. Don't take the quiz for 5.1 because it combines with 10.2. Take it later. But whatever quiz you have for 5.2, 3, 4, take those quizzes. So in 5.1, we talked about exponent rules. And in these 3 sections, there are no more exponent rules directly, but we are going to apply those rules a little bit to add, subtract, and multiply polynomials. Now you may wonder, what is a polynomial? Well, I told you before in our first exam, but I'm telling you again, polynomial has only one special characteristic. What is that? The power or the exponent on a variable, all the powers have to be whole number positive, means integers. Not integers, natural numbers. If your variable has only whole number positive powers and you don't have anything on the denominator, any variable on the denominator, then it's a polynomial. One example of a polynomial is here, 2x to the 5 minus 3x squared plus 1. There are 2 powers here, 5 and 2. Both are positive, both are whole number. So it's a polynomial. A counter example of it being polynomial is the second one. X to the negative 5 minus 3x squared plus 1. We have 2 powers here. One is negative 5, another is negative 2. Since they're negative, so it cannot be a polynomial. Polynomial has only positive whole numbers. If you have negative or fraction or decimal, then they are not polynomials. Now, when you have a polynomial, they have few important parts. The first part is degree of the polynomial. Degree of the polynomial means what is the highest degree or what is the highest power you see in a polynomial. So in this example where we have x to the 4 minus 3x to the 20 plus 7, which one is higher, 4 or 20? 20. So the degree of this polynomial is not 4, even though it's written fast, it's actually 20. The highest number on your power is the degree of the polynomial. And then whichever term has the degree, term means on the left or on the right, you have signs, addition, subtraction, no multiplication, no division. So this polynomial has 3 terms. One is x to the 4, the second one is negative 3x to the 20, and the last one is 7. These are terms. So whichever term has the highest degree, we call it leading term. So we have x to the 20 here. So you look at the entire term. This entire term is from negative 3 to x to the 20. So x to the 20 is inside this term. That's why our leading term is this entire thing, negative 3 x to the 20. In this leading term, whatever number we have as a coefficient, that's called leading coefficient. So the power is called the degree of the polynomial. The entire term is called leading term. And the number we have in front of the variable, we call it leading coefficient. So this term, before the variable, we have negative 3. So negative 3 is a leading coefficient here. And that's all you need to know for this class. If you take pre-calculus, then you're going to work with more about these things. These are helpful because your degree will tell you what is the end behavior of your degree, end behavior of your polynomial. Means at the end, what is happening to the graph, and many other information. But for now, you can chill with this information. Now, when we add, subtract polynomials, we look at the degrees. Based on your degree, you collect, combine their coefficients. So in this example, we have 5y squared minus 11 minus 3y squared plus 9. So our degree here is 2, and we have 2 of them, y squared and y squared. So to add and subtract, you keep your y squared and just combine their coefficients. So our variable is y squared. We don't do anything with the variable. We keep our y squared. But if you combine 5 minus 3, how much you get? 2. So by combining our like terms, 5y squared and minus 3y squared, we get positive 2y squared. And then the rest 2, we can see easily, these are just numbers. So they are like terms. You combined minus 11 plus 9, and how much you get? Negative 2. And that's it, we are done. That's how we add or subtract. We add or subtract only the coefficients. We don't touch the degree. But the multiplication is different. In multiplication, you have to multiply the coefficient. Also, you have to add the degree. Now comes the next example from your homework. It says subtract the polynomial, bless you. Subtract the polynomial 9y squared minus 2y minus 2 from the sum of the two polynomials 7y squared plus 1 and 5y plus 8. What does sum mean? Addition. So basically they are saying subtract the third polynomial after you add the first two polynomial. So let's add the first two polynomial. We have 7y squared plus 1, and our second polynomial is 5y plus 8. And now we are going to subtract our third polynomial, 9y squared minus 2y minus 2. But I did something wrong here. Parentheses. Why? Because anytime you subtract more than one thing, they will change the sign. If you subtract a minus, it will turn into a plus. If you subtract a plus, it will turn into a minus. So subtracting is dangerous. Anytime you subtract, they will change the sign. So that's why for addition, we didn't have to put parentheses because addition is simple. Their life is easy. But subtraction is a tricky one, the bad one. We have to be careful about subtraction. Every subtraction will change our sign. So 9y squared is positive, but it will turn into negative. Then we have negative 2y, but it will turn into positive 2y. Then we have negative 2, it will turn into positive 2. So every subtraction changed the sign. So at the end, we have minus 9y squared plus 2y and plus 2 for the subtraction. And we have 7y squared plus 1 plus the 5y plus 8. So now we have entire thing without any parentheses. So we collect like terms. There are many ways you can collect like terms. You can combine like an arrow, like I did in the last one. Or if you want, you can put everything together on a vertical line. For example, I have 7y squared here and negative 9y squared. So let me put negative 9y squared here and cancel that. Then I have plus 1. So I have two others number. One is plus 8 and another one is plus 2. So put them together. And then you have 5y and 2y. So write 2y below the 5y. So you can see clearly what are the like terms we have, and we can easily combine them. You don't have to do that. You can do everything mentally, but if you do that in the exam, you're not going to make mistake. So we have 7y squared minus 9y squared. How many y squared we have? Negative 2y squared. And we have 1 plus 8 plus 2. How much total? 11. And lastly, we have 5y plus 2y. 7y. Now, this is not wrong. This is correct. But our degree is in wrong order. So to make it look nicer, we can write negative 2y squared first, and then 7y, and then 11. They both are same. This one is just in organized way, and the previous one is not in organized way. There is no mistake. It just looks to be different. And this is my square, okay? It looks like a bird. That's why I'm adding 2. This is 2. And that's how we add or subtract. Any question? Was any step unclear, confusing? Okay, then enjoy the next one. So I am planning to give at least one of these in the exam, where you're going to add and subtract polynomials. And only one of these will do that. Only one. Let me take the attendance now. Sylvia? Hey, Christian, Christina, Christopher, Daniel is missing today. Develot, missing today. Dennis, Idalis, Jared, Jay, Joshua, Justin, Caitlin, Kelly, Kyle, Lady, Muntaha, Nayari, Nicholas I, Nicholas S, RST, Rana, let's see, Ricardo, Raj, Mora, Zichi. Who would like to be my volunteer? Muntaha. Mm-hmm. 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 Perfect. And then? And then it's gonna be negative x because 7x minus 8x negative x plus 9. 17 and 1, 18, and so positive 9. That's it. And if you cannot do it mentally this way, write this down one after another. For example, we have 2x squared plus 7x minus 9. Then we have another 2x squared minus 8x plus 1. And then we have plus 4x squared plus 17. So you can see all the terms. This gives us 8. This gives us minus 1. 17 plus 1 is 18. 18 minus 9 is 9. I do it so that I can see all the terms. And it helps you to see all the terms. So you're done with one exam question. Now comes the multiplication. We are going to start with something easy. One term multiplying with one term. When you have one term, only one term, we call them monomial. Monomial. So you're multiplying one monomial with one monomial. When you multiply them, we multiply the number with the number. And then we multiply the variable with the variable. So we have negative 6 times 5. And we have n cubed times n to the 5. Now multiplying numbers is easy. We are used to this. What is negative 6 times 5? Negative 30. And now for this, we are going to go to our exponent rules. Do you remember the exponent rule we had before? If you have x to the m times x to the n, what do you get? M plus n. We add the powers. So for n, we get n to the power 3 plus 5. That gives us 8. So for addition and subtraction, we add or subtract the coefficients only. We do not multiply the powers, or we do not add the powers. But in multiplication, we have to add the powers and you have to multiply the coefficients. Any question? So all these things are rules. You have to remember your rules, your exponent rules, and you can apply them easily. Addition, subtraction means add, subtract coefficients. Multiplication is two things. Multiply coefficients, add the powers. So double work. And now you have a monomial and a binomial. So two terms are called binomials. This is our one term, this is our second term. So multiplying monomial with binomial. Can you guess what you're going to do? Distribute. Good job. We take our monomial negative 4x and we distribute to the first term in our binomial. And then we do the same thing for the second term. We take our monomial 4x and we distribute it to our second term in the binomial, which is 7. And now we're going to do the exact same thing what we did in the left page, but we're going to do it twice. So multiplying negative 4 and 9, how much you get? Negative 36. And combining x times x to the 4, how much? X to the 5. You add the powers. See, multiplication rule for the variable. You add the powers by keeping your variable once. And then we have negative 4 times 7, negative 28. And we have only one variable here. What is our variable? X. We have nothing to combine, so we are done. It doesn't matter how many terms you have to do the exact same thing. Take one monomial from every polynomial and keep multiplying them. Bless you. Any question? Now these are too easy, so don't expect to see this in the exam. What you're going to see the exam is the next one. Also, you're going to see this in the final. So we have 2 terms, we are multiplying 3 terms. Can you guess what's the name for 3 terms? Trinomial, good. So you're multiplying a binomial with a trinomial. You don't have to know their names, but their names are fun, so why not? Monomial, binomial, trinomial. So we do the same thing. We take one monomial from the first binomial and multiply everything in the trinomial. And then we take the second monomial in the binomial and multiply everything in our trinomial. So either you can do it the way we did in the left side, or there is one method I found in common in most of the students called box method. You make a box and you keep multiplying everything and then combine like terms. So whatever is easier for you, you can use your method. Let me show you the box method first, because I realized box method actually is better than, helps student better than the way we did in the last one. But you don't have to know this if you don't know or if you don't like. So in the box method, you write your first polynomial horizontal, vertically. So we have 4x minus 3, and you make a box. And then you write down your second polynomial horizontally. So we have 6x squared minus 5x plus 2, and then you make box for each one of them. And then you multiply them. So you take your first term here and you multiply the entire box one by one. So what is 4x times 6x squared? 24. And how many x we have? 3 of them. Perfect. Then you do the next one. Negative 20, how many x? 2 of them. And then you do the last one. I should have made my box better so they can see. Let me go this way. 4x times 2. 8x. So take the first term and multiply the entire second polynomial. And then you go to the second term. So second term is negative 3 here. You take this entire 3 terms and you multiply them here. One by one. The first one is, so let me think that this box is not here. Okay? So ignore this box, multiply 3 with this, 3 with that, 3 with that. And write down the answers in the second box. So what is negative 3 times 6x squared? Negative 18x squared. The next one, negative 3 times negative 5x. Positive 15x. And the last one, negative 3 times 2, negative 6. So you're done with multiplication. Let me erase all these tiny things so you can see everything clearly. Now you combine like terms. So let's start with this one. Black. The first thing you see, the cubic term. Do you see any other cubic term here? So we have only one cubic term, 24x cubed. The next one is a square term. So we have one square term here. Do you see any other square term? Yeah. Here. So you combine them. So how many square terms do you have? Negative 20 and negative 18. Negative 38 square term. And then we have, let me change the color to lavender. We see x term. We have 8x here. Do you see any other x term? 15. So we combine these two and we put them together. How much is 18 plus 15? 23x. And the both are positive. So we use cubic term, we use x squared term, we use x term. What is left? Negative 6. So we just put it down. It doesn't have any friend. It's lonely, just like cubic. And you're done. So if you want, you can use this box method. Or if you want, you can use the distribution method. Whatever is easier for you. So go ahead, enjoy the next one. Same method, same everything. I don't know it fix my attendance now. Shape. Christian. Danielle, still not here. Devlat, still not here. Jared, still not here. Rana, here. Ricardo, not here. So absent is Ricardo, Jared, Devlat, and Danielle. Lady, you're here, right? Christian. Sheikh. Caitlin. And Lady. So people who are late or who didn't hear my announcement from last class, whatever mistake you made, you can fix those mistakes and you get 10% of whatever points you lost. But to fix this mistake, you had to work with the tutor. Once you work with the tutor, I uploaded the blank exam here. So you print it out, or if you have a tablet, you can simply write on that. And once you get the information, like who is the tutor? Is it from SEEK? Is it from SAC? Or is it your PLTL leader? Whoever tutor is, write their name down, their email. The blank exam is below that. Once you complete your blank exam correctly, convert everything into PDF file and then upload here. See, in the test correction, you click on the test 1 correction and upload everything by next week, Thursday. After next week, Thursday, I'm not going to accept anything. There is no physical copy, okay? Upload everything in here so that I can have a digital copy. And you have your physical copy so that you can study that for your final.
Do we need to put everything other than the ones we got correct?
It will be better if you fill out the entire thing. You already have your right solution with you. You just have to fix the wrong one and then put everything together. Okay, ready? Not yet? Yeah, ready? Okay. Kyle, would you like to help me with this? Which method do you use, the distribution or the box? Okay.
Starting with the x squared.
Mm-hmm. 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 Perfect. Mm-hmm. 16x to the 5th. 40x to the 3rd. negative 14 x to the fourth, negative 35 x squared. Six x to the third, and then positive 15x. Perfect. Now it's time to combine. Negative 14 x to the fourth, $40 and 6. When you combine, you get positive 46 x to the 3. Plus 15x. Good job, you got it. I meant a box.
You didn't add the both three exponents. You leave it like
because in addition, you only add the coefficients.
Okay.
In multiplication, you add powers. In addition, you simply add the coefficients. Okay. Question? Not bad, right? So remember, exam question, final exam question. So with this, we are done with addition, subtraction, multiplication. And now comes there are two special multiplication. They're special because you didn't have to distribute them to get the product. You can simply use special formulas. The first one is called binomial squaring. It means you have the same binomial with a square power. So a plus b, which is square. Our base is a plus b. Our power is 2. So the power is telling us multiply your base, a plus b, 2 times. So a plus b times a plus b. Binomial squares, a product of the binomial, same binomial. Now you can use the distribution or the box to get the answer, but you don't have to. There's a shortcut. The shortcut says it doesn't matter what do you have inside your binomial. At the end, the result will be the first number or first term square plus the second term square. So you have first term A, second term B. So you have first term square plus the second term square always, and then twice their product. The sign for their product, it depends on what sign you have in your binomial. If you have a plus sign in the binomial, then you're going to add twice their product. If you have a minus sign in the binomial, you're going to subtract twice their product. So it doesn't matter which method you're going to use. At the end, this is the scenario.
Second line there, we put the arrow down to b squared. What does that say in parentheses?
Base. Remember, power tells us multiply base how many times. So base is a plus b. So you're multiplying a plus b, same a plus b twice. Now using this formula, we can do this one. We didn't have to use FOIL because we are lazy. We have to use all the shortcuts. So the rule says, take your first term and square that. So if you square 6x, what do you get? Good job. 6 squared x squared, that gives us 36x squared. And then the formula says, add the second term square. So our second term is 3. What is 3 squared? 9. So first term square plus second term square. And since it's a plus sign, so we are going to add 2 times their product. So what is 6x times 3? How much is 6x times 3? 18x. And what is twice the 18x? The double of the 18x is 36x. So if you want to write in decreasing power order, this should be 36x squared plus 36x plus 9. In reality, we don't have to write all these things. You can go from the first line to the last line directly by doing all the math mentally. For example, 6 squared x squared is 36x squared. 3 squared is 9. And then 2 times 6 times 3. So 6 times 3 is 18. 18 times 2 is 36. So we have 36x. That's why this is called shortcut, because you can skip all those steps. But you don't have to memorize the formula if you don't like it. If you do memorize it, it will save your life. It will save your time so much, and it will make your life so much easier. I remember learning this in our country in 4th grade or 5th grade. And after that, I actually never used for this type of question. I always use this formula. And I love it. Okay, the second type of formula you have to memorize.
Where did you get the plus 2 from?
It's
Like,
from the formula.
Okay, the 2 just in the formula?
Huh? And again, if you don't want to memorize the formula, it means they're telling you multiply 6x plus 3 times 6x plus 3. So you can use FOIL, this, and at the end, you get the same result. So again, this formula you don't have to memorize it if you don't want to. But the next one, you must memorize it. The next formula is saying, if you have 2 same terms, but their signs are different. So a plus b and a minus b. We have same a, same b, just their middle signs are different. They have actually a special name. We call them conjugates. So if you multiply 2 conjugates, you can use FOIL, but don't waste your time. Why? Because at the end, after you multiply, you're going to get the first term square and always minus the second term square. Always, always, always. So you must memorize this. Multiply 2 conjugates. Conjugate means same terms, just their signs are different in the middle. If you multiply them, the result is first term square minus second term square. And if you observe the result, we have 2 perfect squares and a minus between them. So they have a special name. We call them difference of perfect squares. So for difference of perfect squares, we can actually go backward. If they give you difference of perfect squares, we can factor them. What factors we get? 2 conjugates. The bases, you add them, times you subtract them. That's the factors. So we are going to go backward from right side to the left side in chapter 6. In chapter 5, we are multiplying the conjugates and get the difference of perfect squares. Clear? So I gave you the 2 formulas. Now it's time to try them. Try the first one. 5x minus 2y whole thing square. I may give this in the exam, may. But definitely I'm going to give the other one in that sum. The binomial, trinomial thingy. No, these. Definitely one of these. And for special, I think let's see. Ricardo. Ready? Any volunteer? Christian.
First, worst. Wait, look, I like to do step by step. I didn't.
Tell me your mental process.
So you have 5x squared, so that's 10x to the second power.
Really? What is 5 squared?
I'm sorry, 25.
25.
And then you have negative 2y squared, which is 4 to
No, it's always positive.
oh, it's always positive.
Always positive.
So
2 square, y square.
we have 4y.
4y square.
You have 5x times 2y,
5x times 2y.
and then you get 10y, 10xy.
Mm-hmm.
And then you multiply
Negative 20 sy. That's it.
why would it negative 2 this time?
That's the rule. 2 times their product. And that 2 will get the sign from the middle.
Okay.
That 2 either is positive or negative. It depends on what is given to you. But the squares, the perfect squares, they always have to be positive. So 5 square x square is positive. 2 square with y square is always positive. When you take their squares, they're always positive. But the middle sign, it depends on what is given to you. In the last one, we are given the plus sign. So we had plus twice their product. But this time we are given the minus sign in the middle. So it's negative twice their product.
Did you add 2 and to get that, or
10 plus 10. Go ahead. No, that doesn't matter. Usually when we have x and y, we write x, all the x first and then the y. That's why. But if you write 25 square plus 4y square minus 10 xy, it's right.
Can you try to do it like with the FOIL method?
Yeah. The foiling method. Mm-hmm. We have 5x minus 2y squared. So remember, square means multiply your base twice. So 5x minus 2y, 5x minus 2y. Same thing twice. And then you either box method or FOIL method, whatever you want to do. You take one element and you multiply every element in the second binomial. So 5x times 5x. Then you get the second element, you get 5x times negative 2y. And then the other way around. You have negative 2y, you go to the 5x. So negative 2y, go to the 5x. And lastly, this negative 2y goes to this negative 2y. So negative 2y times negative 2y. And then you combine them. Not combine, like multiply each monomials. So what do you get from here? How many x squared? What do you get from the second term? Xy. You cannot combine them because they both are different. So you put them together, x and y. Then you go to the third term. Negative how much? Negative 10xy. And lastly, positive 4y squared.
That's in my last term.
Mm-hmm.
Positive 25x squared, positive 20x, y.
Positive 25x squared, positive 4y squared. And in the middle, we have negative 10xy, negative 10xy.
Positive 20x.
If you have the same sign, you keep the sign, but you actually add the numbers. So 20xy.
So that's only
This is distribution.
and that's over 4.
Well, so see, if you do this, you have to do so many steps. You have to do so many calculations. Why someone is this? I hate this. So that's why if you remember that other formula, it will save you time, but you have to remember it correctly. Sorry, 10 and 10 is 20. I said 20, but I wrote 10. You have negative 10 and negative 10. Total is negative 20. Try the next two. It's the second method. Say it again.
Oh, we know they're different. Mm,
They look same, but actually they are not same. Their signs are different. Same thing here. Their signs are different. So if you have the same thing but signs different, do you remember what do you call them? I just told you a few seconds ago. The result is difference of perfect squares. But what do we call each one of them? What's the name of this pair? Conjugates. We call them conjugates. Conjugate means they are same, only their middle signs are different. So if you multiply any two conjugates, the result will be same. Difference of their perfect squares. So don't waste your time on foiling. Just tell me the answer. What do you get from here? In the first one, x squared. And I always minus And what do you get the second one? 1 square. So x square minus, what is 1 square? 1. That's it. I didn't do anything. I mean, we did do math, but no hard math. Simple ones. Who would like to volunteer for the last one? You each tried one. Anyone else besides Mayari? Lady? So 4 square x square. And then always minus 3. 3 square. So from here we get 16x square. And from here we get 9. See how simple is this? We don't need to do FOIL. Say it loud, I didn't hear you. You can, but why don't you waste your time? If in the exam we don't have much time, but you have to do it in 1 second. Would you like to use the box method for that? You don't have time. The shortcut. Take the first one square minus second one square. Yes, you can definitely use the box method, but I recommend don't get used to it that. It's a bad idea. Okay, any question? Now we can go backward from here to there, but the direction will say factor. If they give you this and tell you to factor, then it's easy. Square root of this and square root of that, you add, you subtract. And you're done. The factoring is coming in the chapter 6, after you're done in 10.2. So any question on our chapter 5? With this, we are done with chapter 5. So your homework is section 4.5, 5.1, 5.2, 5.3, 5.4. Always. That's why the result is called difference of perfect squares. So this is difference, means minus. And these are perfect squares. So difference of perfect squares. Multiplying conjugates, result is difference of perfect squares. And factoring difference of perfect squares means your factors are conjugates. So try them by twisting. And if I see these are too many questions, probably I will extend time.
Which is
Hmm? 5.1, no quiz. Because 5.1 comes with 10.2. And 10.2 is what is coming now. We're not going to start, but write down all these rules. 10.2 is based on all these rules. It's one of the worst section. But it's a fun section if you remember all these rules. And if you're sucks memorizing these rules, then 10.2 is bad. No, exam, we only did 4.5, so no more 4.5 for the exam. But homework, you didn't do your homework yet for 4.5. So make sure to complete your 4.5 homework and quiz. And our exam will start from 5.1. So write down all these rules. The first rule says if you have a square root, it means it's x to the 1/2 power. So square root is not a polynomial because our power is not a whole number, it's a fraction. The next rule says if you have a cube root, it's same as x to the 1/3 power. So anytime you have a radical, the radical turn into a fraction power. That thing inside we call them index or root. And that thing inside the radical, we call them radicand or base. We call them base when you write them as exponents, and we call them radicand if you write using a radical sign. The index, root, or radical. The radical symbol has 3 names. The number is index, this is root or radical, the inside we have radicand. But if you write this in fraction format, the same radicand is now called base, and this index is called power or exponent. So whatever number we have in an index, that goes on the denominator, and 1 is always on the numerator. That's how we can convert any radical into exponents. Now, the fourth rule says, what if our radicand itself has its individual power? Well, no problem. The individual power goes on the numerator, and the index goes on the denominator. And as long as your radicand is a positive number, we can switch around their position. Like we can put the individual power inside the radical, or you can put the individual power outside the radical. The position, which one you do first, doesn't matter if your base of the radicand is positive. This means positive or 0. But if it's negative, then this rule doesn't apply. If the radicand is positive or 0, then maybe you can take the square root first, whatever you get, and then you apply your power. Or you can apply the power first and then take the radical of that quantity. So the first set of rules is converting radical into fraction powers. The next set of rules is negative powers. What do we do with the negative powers? Every negative power turns into a fraction. The whole fraction, not the power fraction. The power fraction comes from the radical symbol. The negative sign converts your whole number into a fraction number. So whole number x to the power -1 turns into a fraction 1 over x. Now this whole number x with -2 power, that 2 becomes the power on a whole number. It's 1 over x squared. In other words, the symbol negative turns into fraction 1 over. So if you have x to the n negative power m, it's 1 over x to the positive m. Now, if your power is a fraction, then you get double fraction. One fraction comes from the negative, so negative is 1 over, and then x to the your fraction power. So it's fraction in fraction. And lastly, if your base itself is a fraction, and you have a negative power, it means this negative will switch the position in a fraction. So the numerator turns into denominator, the denominator turns into numerator, when this negative turns into positive. And then you distribute the power. So you get x to the negative n turned into positive n, and y to the negative n turned into y to the positive n on the numerator. So these are all the rules you have to learn for this class. I gave you 2 sets of rules before, and now another 2 sets of rules. Enjoy them, memorize them. These are too much, I know. But remember in the exam, how many points will be on these rules? 35. So I'm warning you guys. Make sure you learn all the rules correctly. In the exam, I'm going to give you the rules themselves, but some numbers to test you. Do you know your rules, how to apply them? So write down all these rules together in one piece of paper, and every day from today, keep looking at them for 5 minutes or 2 minutes. Keep looking at them. The more you look at them, the better they get stuck in your brain. So have a good weekend. Enjoy memorizing these rules and the homework and quizzes.
What is the meaning of X and over where X is
But these rules true only if you base either the 0 or the positive number. If your X is a negative, then this doesn't apply. You are late. What happened?
My train blew up. No, I'm not.
And you are alive.
No, so I come from like Far Rockaway, far. It's in the name. Also, just because of the snow, it's just it's been really slow. But also with the A train, there's like a 20% chance they have to cross a bridge. If that bridge it's open, they have to let the boats pass. You have to wait like 20 minutes. I was stuck at Broad Channel for like 10 minutes. Yeah.
Wow.
I tried really hard to get through math. Like I really like math. Like I couldn't.
Recorded everything, so make sure you watch the recording. Whatever you missed.
Well, it just seems like you're talking about factoring, so.
No, these are factoring, but before we did addition, subtraction, multiplication, all these things. These are bit, right? But you still have to refresh your memories from before.
Look at the video. Oh, I was supposed to print that out.
Yeah. And then take pictures and then upload in a single PDF file. Or if you have a computer, just write everything on your computer or tablet or laptop, and then you can just convert into PDF and then upload.
Yeah, so I can just
like the way I do. You can write everything here, and then